I would like to know that what are the different types of materials that your company is offering?
Basically, the TANAKA is a precious metal based technologies we supply. The precious metal means like a platinum, gold, silver, palladium, rhodium, iridium, titanium, and osmium. So it usually have a good function in terms of like conductivities and reliabilities and stabilities as well. And in case of semiconductors, we use in case of semiconductors, we supply the wide range of product from the front end to back end. I mean the assembly and packaging materials as well. Especially the bonding wire is one of our leading products so far. It started like in 1964, and we have the largest amount share of bonding wire so far. The TESHIMA is in charge of that product, so that he can talk about the technology update about the bonding wire. Is that alright? じゃあ、日本語でも大丈夫です。
はい。それではですね、ボンディングワイヤーに関してですけれども、先ほど言われた通り、我々長い時間、多くのワイヤーを供給していますということで、もともとは、やっぱり我々貴金属の会社でしたので、ゴールドで、ワイヤーを作っています。
So, as you do, that we have, our company have been doing precious metals and making precious metals. Our first precious metal is gold. So we make wire using gold, and then we supply the products.
Okay. So, what are the ultra high purity metals?
我々のゴールドワイヤーでいうと、コア9、99.99% っていうのが、通常普通。
Okay, so our bonding wire, gold wire has 99% of purity.
99. So 49.
Okay. Why there is need of such materials in electronics?
やっぱり電気を流しやすい材料として、やっぱり金が一番、特性的には、安定してるし、科学的にも、腐食されないっていう強みがあるので、そういう材料と順番で。
Okay. So actually, gold has good conductivity and it makes electricity flow very easily without any resistance. So that is why we use pure gold material so that we have a good connectivity and good reliability so that it works for longer periods of time.
Okay. So, other than gold, what are different materials that are used and how those are involved in electronics, other than gold?
我々はですね、金以外で言いますと、シルバー。あとは、プレシャスメタルを使ったもので言うと、ここにある、ワイヤー自体はカッパーなんですけど、表面をパラジウムでコーティングしたものを取り扱っています。
Okay, so we not only use gold, we also use silver, and this is the wire which usually for the silver, but we use platinum as well.
I will just add. Apart from the gold wire, we have other precious metal bonding wires as well. One is obviously the silver bonding wire, and then we also have another product line. It's called the PCC. So the PCC is basically the copper bonding wire, but it's been covered, coated with palladium. So as you are aware, precious metal is 8 elements, like gold, silver and platinum group metals, like platinum, palladium, rhodium, ruthenium. So among them also we have many products which we have displayed.
So how these products, as you mentioned, there are many type of materials that can be used. So how we can differentiate that what type of material is supposed to be used for what type of purpose and how those materials are being employed in electronic sector specifically?
基本的に以前は全てゴールドでした。ただ、ゴールドの価格が上がってきましたので、その代わりになる材料としてカッパーが出ました。で、できるだけ多くの製品をカッパーに変えたい。
So there is a historical background from the past, all of the bonding wire were made of gold. But the time depends on the because of the price of gold and cost effectiveness. Decades later, the copper material and other material, including silver, others increases. But still, the gold has really good conductivity and reliabilities as well. So the certain amount, still the gold is preferred in a very high for the semiconductor chips, which requires higher reliabilities so far.
Okay. Okay. So how these materials are refined to be used in electronic sector?
そうですね。我々、その貴金属を溶解、生成も含めてする技術を持ってまして、もともとこのボンディングワイヤーの材料っていうのは、99.999%の材料に我々が、ドーピングをして、コア9を作っています。ということで、その作る過程で、そのコンタミネーションを排除するような工夫を長年続けてやってきました。
So it's like we have decades of experience in recycling and refining of precious metals from industrial waste. So based on that, we are able to increase the purity up to at least 5 nines, like 99.99%. But as you are aware that we are operating in the 4-9 for the bonding wire. So what we do is to enhance the properties of the material, we put in additional materials and get to that concentrated.
So it's mentioned that recycling is done. So how that is being done and how it caters to sustainability?
Okay, basically we have two sources for recycling. One is the production scrap, which comes from customers' factories. And the second is the urban mining. It's made from the final product from the market. So we have the long career in recycling precious metal and precious metal containing product. 二つあって、ちょっとダッサン言える範囲でお願い。二つあって、一つは、溶媒抽出ってわかる？液体の中で分離していく。もう一つは、乾式って乾いた方式って言って、他の、例えば鉄とか銅とか、そういったものに貴金属を吸わせて、そこから分離していくって、二つありますね。
So, in terms of the technology where we are recycling and refining our precious metal, so normally as was explained, that one method is like where that is extracted from the liquid extraction. So the metals remain, so the metals get converted into the liquid phase, and then that gets extracted using columns, like the absorption columns. Another method is like conversion of the type of the oxidation state of the metal itself by reacting with other materials, like for example copper or iron, for example. So that helps in actually extracting the materials, like precious metals, from the system of different materials.
プレシャスメタルの濃度が濃いときは、だいたい液体の中で処理します。で、プレシャスメタルの、濃度が薄いときは、だいたい他の溶かして、他の鉄とか銅に吸わせて、まず処理しますっていうのがあるんですけれども、それ両方のプロセスを田中としては、ずっとこれまでやってきているので、両方のプロセスをやることができます。
So the two processes that we explained just now, depending on the concentration of the precious metal in the waste scrap, we identify which method to actually select. So in terms, if the concentration of precious metal is high in the electronics, like in terms of the industrial scrap, then we go for the liquid extraction. So we convert the precious metal using proprietary technology to convert them into liquid phase, and then from the liquid phase we extract it. If the concentration is low, then we actually use other metals to actually react the precious metal with that, and then are able to refine it through subsequent steps.
Okay, so what are the challenges that you came across while following the procedure, and how you tackle those challenges?
In terms of the method,
The
of
method that is
recycling,
being adopted, yes.
大体リサイクルポイントは3つだと思ってまして、1つはサンプルをうまく評価すること、エバルエートすることですね。例えばその中にどれぐらいの貴金属がどこに入っているかっていうのを均一にサンプリングすることがすごく難しい。で、2個目は、それをどうやって取り出すかっていうところが、いろんな合金になってたりとか、あとは金属以外の成分もたくさん含まれているので、取り出す技術。で、3つ目は、それをちゃんと評価する技術。で、その3つが、チャレンジというか、技術を。
So we have three steps while recycling. First of all, we choose which metal to be extracted. So along with lots of metals, we choose which metal is to be extracted. Then we actually decide which way to use to purify that particular metal in order to make it to the next semiconductor, the apparatus. And then third, the actual process makes it difficult. So it depends on the actual process has more difficulties, but we have three processes of recycling particular material.
So just to add on to that, actually, so first thing that we need to understand, like once we get the industrial scrap, from where we actually recycle and refine our precious metal, we need to know how much is a percentage. Like unless we know it, like we explained, like depending on the concentration, we select the right proper steps. So the analysis is the first critical point. Sampling is the first critical point. So first we do the sampling, and then based on that sampling method, we decide on which recycling step and refining step to follow. And once that is done, then we do the analysis to evaluate the purity of these materials.
例えば、これは、ガソリンエンジンの自動車の、キャタリストですけれども、これは一回粉にまでして、で、均一に混ぜて、サンプリングをする。そういうのが一つの技術ですね。
Okay, so for example, this is an catalytic converter that is being used in automobile to reduce the emission of like the various kind of toxic gases. So it contains a lot of precious metal.
Platinum, palladium, rhodium as well.
Yes, but then those are all distributed in the whole material. So what we need to do is first break them down and transform them into smaller particles. So doing that, what happens, what helps us is to homogenize the whole system. Thereby we are able to have the precious metal distributed in the system. Then we do the sampling and are able to identify, like our analysis team, like our analysis technology is very top grade, and then based on that analysis we are able to determine.
So is there any advancement in terms of high purity material from in the last 2 to 3 years that totally changed the way how R&D teams work in making new electronic components?
最近ですと、やっぱりパワー半導体が、すごく成長してます。で、パワー半導体に対しては、我々、アルミの、太いワイヤーを、供給させてもらってましたけれども、世の中、もうちょっと大電流を流したいですとか、シリコンチップから、SiC に変わったりとか、アリウムナイトライトに変わったりとか、っていう技術の変化の中で、やっぱり、アルミだと電流流すのが限界があるので、もうちょっと電動率の高い銅に切り替えるっていうのが最近の技術の変化です。
Recently,
Yeah.
Recently, we have been using aluminium in order to increase the conductivity and give the electric components to entire world, right? And we found that aluminium is way more good as in terms of conductors. So we have changed we are also using aluminum as a semiconductor in our company.
Okay, just to add on to it, actually, recently power electronics is playing a very critical role in the semiconductor space. So for that, we all, apart from the precious metal category of bonding wire, we have other type, which is the aluminum bonding wire. So we have it in a thick aluminum bonding wire is the product that we have designed. But recently, the technological trend is actually shifting from silicon to silicon carbide and gallium nitride. So the industry is actually looking into those kind of substrates onto which the bonding wires can be attached onto. Now the problem with aluminum is that the conductivity is comparatively lower, so and the adhesivity of these materials onto the silicon carbide substrate and gallium nitride is difficult. So the industrial partners are looking into copper-based materials. So we in the R&D team actually are really developing copper bonding wires, which are actually very useful to cater our customers who are looking to transition from the silicon substrate to gallium nitride or silicon carbide substrate. So
Especially for the power electronics.
for the power electronics sector.
So how your technology is different from the competitors in the market, and how you stand different among them, and why customer will choose your product rather than going to some another
違
company?
いとか強みですね。
そうですね。銅との違いって言いますと、先ほどそのアルミからカッパーに変わるって言ったときに、やはりカッパーだと、硬くなるので、なかなかその接合技術で難しい。ということで、我々の強みとしてはお客様とコラボレーションして、どうにかして、ものづくり、接合技術を、作っていくかっていうのが強みかな。
The industry is actually transitioning from silicon to silicon carbide and gallium nitride for the power electronics sector. But compared to our competitors, the strength that we have is our close tie-up with our customers, who are actually the deciding factor, like in this choosing of this substrate. So in terms of that, we have a very close relationship with our customers. So by doing joint
It's word of mouth actually.
joint collaborations and also co-development of the product with our customer gives us the right the real strength. That is one in terms of joint collaborations. So we directly collaborate with our customers to develop new products. Another thing is that in terms of aluminum, in the technical challenges, when you transform from silicon to silicon carbide, copper is very difficult to actually bond. Like it's very hard. We call it, it's not soft. The technical term is that copper softness is low. So what happens is while bonding, it damages the substrate. Like the whole substrate gets damaged. So the reliability of the overall power devices reduces when you are actually developing copper bonding wire. So through joint collaboration with our customer, we are able to develop soft copper materials and help in the reliability of this kind of materials.
Okay, so in what researches are there in pipeline as compared to whatever is happening right now? So what research and advancement that are being planned 3 to 5 years down the line? And secondly, do you also customize as per the requirement of the customer, or as in depending upon their feedback, or any customization is there, whatever they will be requiring?
そうですね。カスタマイズのところで言いますと、我々スタンダードの製品はあるんですけれども、そこからお客様の要求に添えるように、メカニカルプロパティを硬めにしたり柔らかめにしたりとかって、そういう調整は結構フレキシブルにやれるようなスタンスを取っています。
So, これが、this is the picture of bonding wire from the substrate. That he says, depending on the customer's request, we will a little bit change our materials, like a softer or harder or something. So that there are two technologies, white material, and other one more is like a bonding technologies. It's a customer side, so that we just beside the customer's request and what they would like to have a specific product. Yeah, so it can be one of our strengths compared with competitors, because we will do the kind of collaboration materials with customers.
Depending on the request of the mechanical properties that our customer demand, we can actually provide specific initial materials in the R&D phase. So once that R&D phase gets converted and gets vetted by our customer, then we slowly move on into the production phase. And this is how the cycle. So the best thing is we are able to closely work with our customer and co-develop products together, apart from the standard bonding wire materials.
Any information that they want to add, they can add, because
Okay. So
anything related to product or upcoming product line, or any information that you want to highlight.
Okay, so actually also in semiconductor industry, the recycling and the circular economy is strongly required. So that's why we have kind of like a 100% recycled materials for bonding wire in case of gold. So this is a final user's request to the material suppliers as well, so that we produce the gold bonding wire with all the materials which driven from the recycled materials. So it can be it can contribute to the sustainability of the semiconductor industry itself and the security of the procurement as well, I suppose.
That's all for technology. Thank you so much for your time.